Good evening, Tampere. I'm Ossi Hanhinen. I'm also from Futurist, and I am Ohanhi on Twitter. I'm going to tell you what's so special about Elm, and it's actually Elm and not ELM.
Yes, I know.
So let's first remind ourselves what we used to do, like just a few years ago in front-end development. We had jQuery, and we had simple pages, like a simple input field. You could type something there, plug an event listener there, and then just change a title, and that's it. Super simple, super easy. But then as soon as you have something more happening in there, it gets complicated. Like you get race conditions and like overridden changes and everything. So let's fast forward a few years. So React brought this nice functional way of thinking about UIs. Especially as Jukka mentioned, they brought the easily composable view components and everything was good, but as they say on the site, it's just the UI, so it's like just the V in MVC if you think about it like that. So what about the other parts of the puzzle? Well, Redux is the current status quo answer to that question. So what they say is that it's a predictable state container. And how does it work? It's about controlling the state in a very strict way. So this is basically what happens. You have a model, and then you have something happening, and you get another model. And you can actually just like draw it like this. Each of the models, or the like current states, can be mapped directly to a view. So let's drill down to what happens in that single update. So we have the view, and something happens. An action gets emitted. That action gets translated into some updates, which in return produce another model, and that gets mapped into a new view. The updates are atomic, so basically you can think about the world as if it was frozen. Like from when you get the action, it's frozen until you return the new model. This is also called the game loop in other contexts. We sometimes even forget the user from these graphs, but in this model it fits really nicely. So as you can see, the view is something that the user gets as input, and the user produces an output, which is the action. So you might be thinking, I thought this talk was about Elm. Well, actually, what I just showed you is called the Elm architecture. They just took that into JavaScript world and named that Redux. So also, I know that I learn best by putting stuff into new context with something I already know. So I'm going to keep comparing Elm with React and Redux. So as you know, React and Redux, they're JavaScript. And JavaScript is not really a really great language. It's something that was evolved over time, over about 15 years, from something that was just meant for scripting, document write stuff. And then it became an object-oriented programming language. And then it got some functional programming flavors. which led to, for example, React. And basically, you have libraries for everything that you do in JavaScript. So you have Lodash or underscore or Lambda for functional programming style and functional utilities. Then you have immutable JS for simulating immutable structures in JavaScript. And maybe you put RxJS or Bacon or whatever to have like a reactive flow in your application. Now, Elm is Elm. It's a language of its own. It has its own constructs and it's designed for applications. And well, JavaScript it has this concept of one JavaScript, which means that it can only ever grow. So the API surface can only ever get bigger because all the applications that have been written in a previous version or older version of JavaScript will continue to work in newer browsers. Now this is not the case with Elm. Elm has versions, so sorry. In the latest update, they actually removed some syntactic features that people weren't using. So it can actually get simpler over time. And it has functional reactive programming built in. So there's no way of straying from that. You need to build your app in a functional way and using the reactive patterns. So what is functional programming then? I think it's mostly about building small functions that take parameters, don't require anything else, and always return the same thing when you give it the same parameters. This makes it really easy to test and to refactor. Okay, so there's this concept of pure functions, which is like a very core thing in functional programming. So a pure function has no effect on the world around it, and it doesn't have a state of its own, and it doesn't need to access any state outside it. So here are some functions in JavaScript. How do you know if those are pure? This is a trick question. You don't, other than look at how it's actually defined. So the first one was actually a pure function. It got some parameters and it returned something that was directly derived from those. But the second one, well, it does the thing that you expect it to do, but it also happens to fire some missiles in the middle. Well, in real life, you might have like a Google Analytics call in there, but that's basically the same. So you're firing out some HTTP calls while you're just like expecting to make a simple calculation. Now there's also like something you might not mean to do, but just unintentionally change something around. So the setAge function here, it gets the user and it gets the age as parameters and it returns a user, but it has actually changed the original user here. So that might be intentional or it might not be intentional, but you don't know how it's going to do that unless you look inside the function. In Elm, every single function is pure, and you can rely on that fact. You don't need to go inside it and see how it's done. A really nice part in functional programming is something that is called currying, or rather the use of it which is called partial application. Sounds funny, but it's actually a really simple concept. So I'm going to show you a little demo about that. Here's some Elm code. So we have imported some stuff from these modules. And then I have this isCharacterInCastle function. Takes 2 parameters, uses this external function, which is also pure. We can rely on that. And now, in this isPrincessInCastle function, I am applying the princess to that function. And this gives me a function that is still missing the castle. So I can still pass the castle to this function and then get the result. So I'm using it here in the filter. So I got all the castles that are available. I'm filtering it with isPrincessInCastle, and then I'm displaying it here. So what does that look like? Well, the princess is in Bowser's castle. So Mario would be much better off with this, you know. Could have just gone there. If you look at the same code in JavaScript, you can do the same. I'm not saying that you cannot do that, or, you know, but the thing is, it becomes quite a lot of work to make that kind of a function that gets one parameter and returns a function that gets another parameter and then returns something that can actually use those parameters. And also the way you use that function is a bit awkward since you have the double parentheses here. But you know, you can do this, and it's like beautiful in the sense that it's now pure and easily composable and reusable code. All right. So, functional reactive programming. What is that? Well, we just had the static page. That's not what we actually want to do when we're building web applications. So if functional was just about the small functions that always return the same result, then we probably need something else to actually get different results. So reactive programming is about not setting state anywhere or for any object, but instead we define that I want to listen for changes and I can react when that change happens. So how this is actually done is that you have a concept of streams or signals or something like that, which is something that changes over time. So, for example, event streams might be a concept that you can reference. In Elm, you have signals to do this, but actually you don't need to delve into what those are if you just want to try the language out. So we can do quite a lot of stuff with just those simple functions that we had. So I'm going to show you another demo of the same thing, but interactive. So find character. All right. We have a lot more things imported, but that's not really important right now. what is important is that we have the model here. We're just defining the shape of the data that we have, and then what we will begin with. So the original state of the world, and it's immutable. So this is, you can think of it as a constant or a function that always returns the same answer. It doesn't matter, it's the same. But yeah, we have a search which is the empty string here, and then we have all castles from the castle module. And then we have the update part. This is something you might recognize from Redux. So we have just the one action, search for, and it has a payload of string. And then we have the action use here, the update function, which just checks for which kind of action are you matching for, and then we update the state. And this is the syntax for setting a single part in a record. So this returns a new record, so it's like immutably changed. And finally, the view. This is somewhat similar to what you saw in the closure script thing. So if you take a look here, we have, well, actually we have a div function here, and then we get parameters for attributes and children. And we have another div inside there for a child, so you can like build trees with this. But just like in ClojureScript, this is all functions. You can compose them as you want. So I have this input field as a function here. I could parameterize it and just use the function, you know. But in any case, I'm taking the castles in the model and I'm filtering them by the search string, and then I'm mapping it to the view, which is defined in the castle module. I don't need to know how that is done. I just know that it's going to return the HTML that I want because the types match. So how does that work in real life, in the browser? All right, so in the beginning we have a search string which is empty, and we get all the 4 castles. But when I start typing something here, Mario, okay, he's in Larry's castle. How about Iggy Koopa? He's in Iggy's castle, wow. And Princess is still in the Bowser's castle. I could actually demo something more with this right now. So now I'm in the debug mode. And if you thought time-traveling debugging was something that Redux like invented, or it's not. And I'm not saying that Elm has Elm was the first thing to use it either, but you know, Elm tools have had this from 2013. But yeah, let's get on with the presentation. So some language features from JavaScript and Elm. In Elm, you have strong static types, which is really, really good for actual production use. In JavaScript, you have like super dynamic types, which like, well, how many of you have seen these things where, for example, an empty string is compared with is smaller than sign to, let's say, a number, and then you get like just crazy results based on I don't know what rules, but you know, JavaScript just tries to do something with those values always, and maybe it will return another number or an undefined or you know something, but it tries to do something with those, and that just doesn't happen in Elm. You cannot even divide a float with an integer because those are different types. You need to first round the float to an integer, or the other way around, convert the int into a float to make that calculation. So you will never have these inexplicable situations where you thought that you were getting an integer from that calculation, but you actually get a float, or the other way around. So as you saw in the demo, you can annotate the types like what I've done here. So this is a type annotation here, right here. But you can also omit them, like in this example. The compiler will infer the types for you. You don't need to type them, but it will still work the same. Now, if you do type the annotations, then the compiler can check whether your intention as a programmer and what the compiler found was true, match each other. So you can kind of focus on coding, and the compiler will help you find the correct answer to your question, sort of. There's also the state-of-the-art error messages. So if let's check this, for example. Well, let's take placeholder here, replace that with 50, 30, and I disabled my linter. Yep, now it's gonna show me, let me read it aloud. The argument to function placeholder is causing a mismatch. Function placeholder is expecting the argument to be a string, but it is a number. So that's what you get. And yeah, you can also bring types to JavaScript with, for example, TypeScript or Flow. Those are great tools, but they require quite a lot of setup, and you need to like consciously think about using the types. So TypeScript especially is really great. So if you're using JavaScript, try out TypeScript. But yeah, Elm can have these guarantees because of the static strong typing that JavaScript in disguise languages like CoffeeScript can't make. Actually, the only ways to make an Elm application crash are to use the debug.crash function or to blow the stack with endless recursion. In short, just you need to handle all the error cases that you might get in any given situation. You don't have null or undefined at all. Instead, you have a maybe type, so you need to provide something that the program can do if there is no value. So this is something that I think merits a slide in every single presentation. There's no runtime exceptions in your front-end code when you're using Elm. But tools. I already showed you what the reactor can do. So it has had that time traveling for a while. And the Elm make compiler is what can provide you with those beautiful error messages. So you can like catch the errors before you even try out the code in browser. And it comes with its own package manager, Elm package, which enforces semantic versioning. So because of the type system, the Elm package publishing can actually see that if your package API has changed, it has to be a major number. And then there's also the Elm format, which can automatically reformat the code to be like a consistent style. So this is what I'm going to leave you with. Go and learn Elm. You will learn to love the compiler. And even if you wouldn't use it in production yet, you will still learn to code in that functional style. You can apply those learnings in JavaScript or whatever language that you use. And when you're ready for it, you will understand the basics of functional reactive programming really fast. Also, it will act like a gateway drug to these hardcore functional programming languages. So if you have like a little bit of, I want to learn Haskell someday in you, this might be like the way to get into that world. So thanks.
Thank you, Ossi. Questions?
Thanks, Ossi. One of the reasons why I like Elm is that you really only have types and functions, not many kinds of things in your program. If you want a constant, you just make it functional, no parameters. But I know we didn't speak of any async stuff, but could you talk about ports a little bit? Because that's a concept that I find personally really confusing in Elm. Maybe what would be the equivalent JavaScript construct in, say, a React program?
That's an interesting question because really there's no equivalent thing in JavaScript. So let me put it this way. Elm is like a safe haven that is like pure and nothing bad can happen inside it. But then there's the vast open sea of JavaScript, and anything can happen out there. But then you have these ports which have border control. So if something tries to sneak into the safe haven through that port, the border control will try to see if it fits what you expect it to be. So if you're expecting a shipment of whiskey, you will like check that, okay, this is actually whiskey, so we can bring it in the Elm application. And then the other way around, the Elm application can put out stuff into the sea, but it doesn't make any assumptions of what's going to happen out there. So it's like, well, you get the idea. So the Elm application itself is going to be safe, but whatever happens outside it, no one knows. And the ports are the way to like put stuff out there and get something back.
Any more questions? I have one. I was wondering, you said 0 runtime exceptions. So what if I make a user interface that has an input field and I can type any text, but any number, and then a division is done with the number. So I can then type 0 there, and you cannot divide by 0. So does the compiler like make you do an if check of some sort for every input, that if you are doing a division, then you cannot use the number 0, or how does that work actually?
That's a nice question. I haven't actually tried what happens if you like divide by 0 in an Elm application. I guess that might be the third way of like getting something that should not. No. Actually, they have defined what's gonna happen at that point, and it's still an integer, but I don't really remember what maybe it was like infinity is part of int or something.
Cool. Any more questions? How do you fire missiles?
Yeah, good. Good that you asked this question. So you would make a function that returns a list of missiles to fire.
But how do you do the actual firing?
Yeah. So for that you would use tasks, which are the like, you can do async stuff or basically any kind of effects. Not side effects, but effects, since they are explicit. So that's the way of like putting out something that will change the world. Elm is not about eliminating effects, but it's about putting them in a single place where they can be then executed.
Oh.
Only futurist people are asking questions.
Hi, Ossi. Thanks for the presentation. I'm Joni from Futurism.
Hello.
Let's make a scenario like you've written your safe haven application and it's working totally perfectly. What if there's a need to embed some view code or something nasty like inside of the Elm application? I understand that the ports kind of like help when you have to call some external libraries or something like that. But for example, what if your customer sends you like an add component built with React or something like that? Can you embed something like that as a leaf in your view code in hyperscript things or whatever you're using in Elm?
Actually, you can't. So you will have to somehow externalize that. So, well, this is a long subject to talk about in like broader scale, but as an example, you can make a div in the Elm application with a specific ID and then pass that ID through the port and then have some JavaScript side that will react to that event and then do whatever DOM manipulation thing you need to do.
But basically, like it's still doable.
Yeah. Everything is doable. It's like it's going to require some boilerplate code, definitely, but yeah, it's doable.
and it might break some time debugger or something like that in the process, possibly. Yeah.
Yeah.
Okay. Well, thanks.
Any more questions from futurized people? Or from anyone else? Once again, thank you, Ossi.
Yes. Thanks.